Which one of the following works best as the reaction steps to carry out the conversion below? In order for us to do this, we first must look at the reactant and the product molecule and see what happened, what changed. In the reactant, we see that we have an alkene, we have a double bond here. And in the product, we see that we no longer have the double bond, we no longer have alkene, and instead we have CHO. CHO is an aldehyde functional group, and the way for us to redraw this molecule so we can see it more clearly, I'm going to do a line bond structure is one carbon, second carbon, and a double bond OH at the end. So CHO just means that you have a double bond O with an H at the end, which is an aldehyde functional group. Now that we know what's happening, so we're going from an alkene to an aldehyde, let's go ahead and look through all of the answer choices to see which one would be correct. And we actually will have to do it out because there are multiple steps, so we don't get confused and we get to the correct answer. So let's go ahead and start. I'm going to redraw my molecule. I'm just going to put my benzene this way, and instead of the double bonds, I'll just do a circle to make it quicker. And I will put my double bond here, line draw in the line structure, and I will start with Br2. What Br2 does is it turns, double bond will turn into a single bond, and two bromines will be added, one on each carbon from where the double bond used to be. So we turn our double bond into a single bond, and we add two bromines, one on each carbon from where our double bond used to be, which is here and here. Next, we have NaNH2 axis. And this is a base that is used to do elimination. Elimination is a reaction that creates double bonds. So we see we have two bromines, and halogens, bromines and chlorines and iodines, they're good leaving groups. So we have two good leaving groups on our molecule, and we can do elimination, which requires a leaving group and creates a double bond. Because there are two leaving groups and we have this base and axis, instead of eliminating one leaving group and creating a double bond, it will do it twice. So it will get rid of one bromine, make a double bond, and then it will get rid of the other bromine, make another double bond. So it will result in the creation of a triple bond. So let's go ahead and show our triple bond. And the way I have to draw a triple bond is it has to be straight. It has to be a 180-degree angle here. So don't be confused. I did not lose any carbons. I still have one carbon here and one carbon here. We still have two carbons. So again, what this reaction does is it will eliminate two leaving groups and it will create a triple bond between them. And this is what we have shown. And then my last reaction is H2O, HgSO4, H2SO4, which is Oxymercuration. And what it does is it gets rid of the triple bond. So let's go ahead and get rid of the triple bond, and it adds double bond O to the most substituted carbon from where the triple bond was. While our triple bond was between these two carbons, this carbon is connected to two carbons, so it is secondary. This carbon is connected to one carbon only, so it is primary. Therefore, this carbon is the more substituted carbon, and we will put double bond O right here. Now, if we compare this product to the product that we're looking to get, we see that the double bond O is in the wrong place. Here, double bond O is on the more substituted carbon, and here it is on the least substituted carbon. We have an aldehyde, we're trying to make an aldehyde, but here we made a ketone. Therefore, A will not work. Let's go ahead and do B. So again, I start with my benzene ring with an alkene, and I will do step number 1 and step number 2. So step number 1, B2H6 diglyme, and step number 2 is H2O2 and NaOH. These steps go together. This reaction is called hydroboration. Actually, usually for hydroboration we see BH3, CHF. Here they're using a different form of this reagent, but it still has boron, so this is hydroboration. And what hydroboration does is it gets rid of the double bond, so we will create a single bond, and it adds OH on the least substituted carbon from where the double bond was. So this is our double bond. These are the two carbons, and we already said that this carbon is only connected to one carbon, so it's primary and it is least substituted, so I'm going to add my OH here. Let's go ahead and do the third step. The third step is PCC with CH2Cl2, and what PCC does, this reagent converts primary and secondary alcohols into a double bond O. So let's go ahead, and we see that our OH is on a carbon next to one more carbon, and what it's going to do is it's going to convert this primary alcohol into a double bond O. So we're going to go ahead and show it as a double bond OH. Now if you look at the product, we can see that this product is exactly the same product as what we're looking for. So this indeed must be my correct sequence of reagents. Now let's just go ahead and look at C and Z, and then we will be just to see that why they do not work. I will just talk about it instead of writing. So H2O with H2SO4, what this reaction does is it puts OH on the most substituted carbon from where the double bond used to be. So if we get rid of the double bond and we put OH on the most substituted carbon, and then with CrO3H2SO4, it just converts our OH into double bond O. So we see that this C, a sequence of steps, will give me double bond O on the most substituted carbon, just like A, and not on the least substituted carbon like we need it to be. So we can eliminate it. And then for the answer choice Z, CH3COOH, that what it does is it makes an epoxide. So basically, I'm going to go ahead and show this one. Why not? So instead of the double bond, we will make an epoxide right here. And then we have NaOH, water. And then this is Na plus, OH minus. And an epoxide with a base attacks epoxide on the least substituted carbon. So we attack the least substituted carbon. This goes up. And what we end up getting is certainly not what we're looking for. We end up having O minus here and then OH here. And that is definitely not our product. So the answer for this should be B. This is Maya from Transformation Tutoring. I really hope that you found this video helpful, and I look forward to seeing you in more of my organic chemistry and general chemistry videos.